welcome to the next installment in a series of videos covering limiting reactant problems. In this problem, we're given grams of more than one reactant, and we need to discover what the grams of product are formed. In order to do that, we need to find out what is the limiting reactant, and that way we know how much product is formed. All right, so this video covers method A, which is just a arbitrary name that we've given the method in which we do various ratios, or we cancel things out as we go. Okay. All right, so we need a balanced chemical equation. We've been using this one throughout these videos, so we're getting very good at writing combustion reactions by this point and at balancing them fairly quickly, in particular this one. When we write what we're given, and I like to write it underneath the balanced chemical equation just for it looks nice. It has kind of a nice setup. I'm given 92.6 grams of propane and 360 grams of oxygen. Now, I see that I'm given more than one reactant, so I do have a limiting reactant problem. I can't just look at the grams and know what is the limiting reactant. It's not just about which one is the lesser number, okay? So we need to get these to moles, and we need to find out how much product can be formed from each. So this builds directly upon the given moles, find moles, method A problem that we did before. All right, so let's just jump in and look at this. So I need to find out how much CO2 is formed from the available of each reactant. First I'll do C3H8. So the available is the 92.6 grams of the propane that I'm given. I need to convert that into moles, grams to moles. I'm going to use the molecular weight. So I need to put grams on bottom so it will cancel and divide out. And moles of C3H8 on top. Now grams per mole for propane, that's 3 12s and plus 8, that's going to be 44.11 grams per mole. And I use the periodic table to figure out the molecular weight. Now I need the mole to mole ratio. All right, so how much C3H8 per the CO2s? I get these numbers from the balanced chemical equation. So there's a 1 out in front of C3H8 and a 3 out in front of the CO2. All right, at this point I have the moles CO2 if I were to stop here, but I need the grams, so I need to do the conversion with molecular weight again. So I need the grams of CO2 per mole of CO2. I put the mole CO2 on the bottom so it will divide out. Oh, grams of CO2, let's see, O2 is 32 plus 12 more, 12.01. So that's 44.01 grams CO2. So when I punch that in my calculator, I will get 297, to the correct sig figs, grams of CO2. Correction, I don't get that. I get 277. I need to check my calculator work. And that's if I use all of the available C3H8. Great. Now let's do it again for the other reactant. How much of the CO2 do I get from the available O2? The available is 360 grams of O2. I got to get grams into moles. Let's see, that's 32.00 grams of O2 per mole of O2. It's on the bottom so I can put it at the top. It's a nice trick of math, or nice quality. I use my mole to mole ratio and pull the numbers from the balanced chemical equation. And then I need to do the final step, which is convert the moles of CO2 to grams of CO2. And just make sure that all my units do what I wanted. And now I have the two numbers I need to compare. Okay, so comparing these two values, the 277 versus the 297, the 277 is the smaller amount, so I know